in the first class discussed about we can classify the languages into imperative, functional, logical, object-oriented, market, all kind of thing, right? So we've got some idea based on some criteria. The languages are going to be influenced and how the languages are going to be evaluated, how they're going to be designed, and trade-offs, design issues, and all. So now we'll see the language categories. The programming language is often categorized into four bins, right? The imperative languages, functional languages, logical, and object-oriented, right? The central features of imperative programming are variable, assignment, statement, iterations, right? Imperative languages like C, C++, visual languages category, comes with the Visual Basic or Visual C++, of course, it's no more now, with drag and drop features and all that, right? Then logical programming language. A logical programming language is an example of rule-based language, right? So they are going to be, you are going to specify the rules, based on the rules, based on the rules, the statements will be written, and we call it as the predicates. So predicate is nothing but a kind of condition, right? So which is going to be executed based on a particular rule which is being specified about that, right? In an imperative languages, an algorithm is specified in great detail. Specify a specific order of execution of instructions or statement must be included, right? You're going to specify the set of instructions to be executed in imperative language in the sequence in an order rather, right? In a rule-based language, rules are specified in no particular order, and the language implementation system must choose an execution order that produces the desired result, right? And the markup languages, right, which are being basically used for the internet, rather, right? So markup languages such as HTML do not specify computations; rather, they describe the general appearance of the documents, right? As I told you, the internet when started, basically the programming on the internet started with static web pages and dynamic web pages, websites, portals, search engines, all that now include, and you are able to carry out all transactions, everything, all domain fields and operations you are able to carry out with the help of the internet nowadays, right? So we can classify the languages into imperative. The example under imperative, you can say C, Pascal, C++, like Visual Basic or C++ and all kind of thing. Functional languages where you have the functions, based on the functions, the execution of the program will take place. Fine. For everything, we will have a function, right? To decrement, to increment, to probably perform any operations, like addition or any other kind of thing, right? So you have list programming, scheme, ML, Haskell, these all comes under the functional programming languages. Then logical programming languages, as we said, the rule-based, where you will specify the rules which does not have any particular order, but it chooses the execution order that produces the desired result. So it itself takes the order of execution, right, to produce the result. Then we have the object-oriented programming languages. After the programming methodology being shifted from the procedural to the data-oriented kind of thing, rather, right? So object-oriented programming language is going to be. So you can see in object-oriented programming languages, the basic features of object-oriented programming language: data abstraction, inheritance, encapsulation, inheritance, late binding or dynamic binding, call it as, and you will have data hiding, right? Polymorphism. These all kind of concepts. Basically, three important features which, when a particular language exhibits, you say it's an object-oriented. They are data abstraction, and the inheritance and the polymorphism, right? So if you do not have inheritance and polymorphism, only data abstraction or encapsulation classes and objects, then you say it is object-based. Like for example, VB is an object-based kind of language. Initially it was imperative, but then it was what do you call with features of the object-based classes and objects, so it has become object-based. Even JavaScript is an object-based kind of language, right? But then it has now been extended. We got what do you call server-side JavaScript is also available, right? And where a lot of features will be included of object-oriented, right? So it has almost become object-oriented, right? So under object-oriented, right? C++, we have Java is really widely used in our academic kind of view, right? But then otherwise we have Smalltalk, Singular. There are many other languages. Probably Python, it's also an object-oriented. So likewise, we have many object-oriented programming. Now, what all you can probably see nowadays, all are object-oriented programming languages. Most of them, rather, right? Markup languages, which are being used on the internet, and basically they've been used to develop some documents like static web pages or the dynamic web pages. But it has taken a very good transform into as I said, portals and all transactions and all domain applications have been executed in this markup by using the markup category, right? We'll see the language design trade-offs, right? See, while probably we have discussed about the criteria to evaluate the language, there are certain criteria we have discussed, like reliability, readability, writability, and cost and all. But there is some self-contradictory among this language criteria, right? I mean, language evaluation criteria, which are said to be the design trade-offs, right? Two criteria that conflict are reliability and cost of execution, right? Reliability and cost of execution, if you probably see, it conflicts with each other. There are some self-contradictory with each other, right? Like for example, Java demands all references to array elements be checked for proper indexing, but that leads to increased execution costs. Indexing, basically, when you are working with arrays, in C you have worked with arrays, you have an indexing mechanism, right? Or the subscript, you call it as the index value which you give. The index value generally you start with 0, right? But you can start with -1 also in C language, right? Or you can start with -2 or any other thing, or you can start with 1 also. For example, if I have declared an array of 10 elements, and in order to point all these 10 elements, the indexing if I'm using to start with 0, then 0 to 9. But if I start with 1, it will be 1 to 10. If I start with -1, it becomes -1 to 8. And the step value which we use is generally, with an increment of 1. But in Java, if you see, it has been fixed. The array index has to start with 0 only, right? The index has to start with 0. So for which the cross-checking mechanisms are required. And Java is, of course, comes with hybrid implementation where you have compilation before and then you have the interpretation. So during the interpretation, again, while giving the inputs for an array, for example, if you are reading the elements for an array during the runtime, then what happens? The referencing, the indexing has to be cross-checked, right? So if they are not starting with, let us say, from 0 onwards, if it starting with 1, or if it starts with -1, then there cannot be a loader. So some kind of checking is required during the execution, which requires certain cost, right? So that's how you can say the cost of execution is, sometimes becomes more, what do you call, expensive, right? So, of course, if you see, the advantage that you get out of it is the reliability, right? because you got now the error-free code. The user, when he's willing to give certain values apart from the index value 0, which we prevented from entering, rather. So the error-free code is being generated. I mean, the conformance of the specification of the instructions is being done, but at a cost, but at an expensive cost, rather, right? So we can say the reliability is inversely proportional to the cost of execution. Fine. C does not require index range checking. So as I said, right, C you can start the index value with any, right? So since there is no kind of what do you call condition to start indexing with 0 itself. So there is no checking mechanism required, rather, right? The execution. So that expense will be automatically overruled, rather, right? Conflict between the readability versus writability. Another conflict. Readability versus writability is another conflicting area, right? Like APL provides many powerful operators and a large number of new symbols, and it allows the complex computations to be written in a compact program at the cost of poor readability, because it is allowing you to execute, like for example, direct operations on complex numbers with the help of operators being overloaded, rather, right? That is of course available in C++ and other kind of programming languages as well. But then it allows you to, like for example, you have matrices or arrays, or they can be treated as here the data structures which can be directly allowed to be performed on with operations, rather, right? So then what happens? The objects which he is going to consider for these data structures are not that readable enough, rather, right? Though it is giving you a good flexibility and good writability there, but then sometimes it lacks of readability, rather. Conflicts between the flexibility, and the safety, the reliability, rather, right? Is another conflicting area during the language evaluation criteria which we have described, right? Pascal variant records allows a memory cell to contain different type of values at different times. For example, a cell may contain either a pointer or an integer. This provides a loophole in Pascal type checking that allows the program to do arithmetic on pointers, which is sometimes convenient. However, thus unchecked use of memory cells in the and it generates a dangerous practice. Instead of Pascal, I'll take an example of C, because we have already worked with C, rather, right? So we have unions in C language, rather, right? Union. What is the difference between a structure and a union? Both of them more or like same, but in structure, for each member, the memory will be allocated separately. So all the members you can read simultaneously. Yeah. Unions, conflicts between the flexibility and safety. Pascal variant records allows a memory cell to contain different types of values at different times. For example, a cell may contain either a pointer or an integer. This provides a loophole in Pascal type checking that allows a program to do arithmetic on pointers, which is sometimes convenient. However, this unchecked use of memory cells is generated. Now, we'll move on to the next slide, implementation methods. We have generally three types of implementation methods for all programming languages, right? Compilation, interpretation, and we have hybrid, which is a combination of both, right? So in compilation, the programs are translated into machine language. The programming language can be implemented by any of these three, right, general methods. Fine. At one extreme, programs can be translated into machine language, which can be directly executed on machine. This is called the compilation implementation. This method has an advantage of very fast program execution. Once the translation process is complete, the execution is fast. For example, C, COBOL, Ada, etc. Right? So if you look at the compilation features of the compilation implementation programming languages, it translates the high-level program into the machine code. Of course, slower in translation, but faster in execution. Compilation process has several phases, right? Lexical analysis, which converts the characters into the source program, into lexical units. Then you have syntax analyzer that transforms units into the parse trees, which represents the syntactic structure of a program. Then you have semantic analysis, generates intermediate code. Then you have code generation. The machine code is generated by the code generation. You can see here with the help of this diagram. Is it visible to all of you? Is my screen visible?
Yes, sir.
No?
Yes,
Is my voice fine or disturbing?
Now it's fine, sir.
okay.
Okay. So the source program, which is when fed to the lexical analyzer, the lexical analyzer is going to convert it into the lexical units with the help of single table. Then you have syntax analyzer, which is now then going to convert it into the parse trees. And these are going to be now, fed as an input to the intermediate code generator or the semantic analyzer. This intermediate code generator work in conjunction with symbol table and optimization to provide you an intermediate code. And this intermediate code is now given as an input to code generator. The code generator is going to then convert that intermediate code into the machine code, which can be directly understandable by the computer, by the machine, right? Then the computer is going to provide the result, right? So detailing the same, again, the lexical analyzer gathers the characters of the source program into lexical units. The lexical units of a program are identifiers, special words, operators, and punctuation symbols. The syntax analyzer takes the lexical units from the lexical analyzer and uses them to construct hierarchical structures called parse trees. These parse trees represent the syntactic structure of the program. The intermediate code generator produces a program in a different language at an intermediate level between the source program and the final output of the compiler. The machine language program. The semantic analyzer checks for errors that are difficult, if not impossible, to detect during the syntax analysis, such as a type error. Optimization, which improves the programs by making them smaller or faster or both, is often an optional part, of course, of compilation. It is desirable where execution speed is more important than compilation speed. The code generator translates the optimized intermediate code versions of the programs into an equivalent machine language program. The symbol table serves as a database for the compilation process. The primary contents of the table are the type and attribute information of each user defined name in the program. The machine language code run along with the form, run along with some other code. The compiler builds all to required system programs when they are needed by user program. Before the machine language programs produced by a compiler can be executed, the required programs from the operating system must be found and linked to the user program. User and the system code generator, user and the system code together are sometimes called a load module or executable image. The process of collecting system programs and linking them to user programs is called linking and loading. It is accomplished by a system program called a linker. The execution of a machine code program on so this is the entire process that I have now described how the compilation implementation will take place, right? So out of this, which you can draw, the compiled languages are faster in execution, slower in translation, and not that reliable, rather, right? Okay. Now coming to the pure interpretation, implementation. The programs are interpreted by another program known as an interpreter.
Excuse me, sir. So what is meant by the term lexical, sir? Lexical.
Lexical units are nothing but the lexemes, right? Lexemes like index, equal to, into, constant, all the symbols the other way around, I can say, right? All the symbols, which are grouped as tokens. Okay, fine.
Sir, what is
optimization?
optimization?
Optimizer basically it is used to compress the code. Your program will be compressed, and that will be that will enhance the execution. When probably you need execution to be at a higher rate, rather, right, than compared to the normal speed, you can go for optimization, which improves the programs by making them smaller or faster. Okay, it converts the program into the smaller and then make it faster. Okay, it is an optional part of the compilation. If you want, higher execution speed, if you desire higher execution speed, then you can go for optimization as well. Yes. So, yeah. Coming to interpretation implementation, programs are interpreted by another program known as an interpreter, right? And then you have the hybrid implementations, which is a combination of both compilation and interpretation, right? So in pure interpretation, the interpreted program on as a simulation software. The interpreter program is generally a simulation software. It's another program, rather, right? So the machine now describe how the compilation implementation will take place, right? It's a Linux operating system. So on these operating systems, you have you use a shell, Bourne shell or Corn shell, or this kind of languages which are interpreter based. They are designed from the machine point of view. They can be directly interpreted on the machine. It is another simulated software the other way around, rather, right? So which can directly make the computer to understand the respective code. In general, if you look at the pure interpreted programming languages, will have the instructions in the form of commands. Sometimes we call as device drivers also, rather, right? Okay. So the pure interpretations implementation programming languages are much slower, around 10 to 100 times slower than the compilation process. It requires more space. It allows easy implementation by many source level debugging operations. For example, array index, outer bound, and all kind of thing. As I said, in interpretation, the execution is going to be done line by line, and before the line being executed, which is going to be checked during the runtime. So it's going to see that whether it is equipped with some kind of error, then it raises as an exception. Like for example, JavaScript or PHP, Lisp, all scripting languages are the interpreted languages. So they are more strongly typed when compared to the compiled languages. I can just list out a few differences between the compiled and interpreted languages here, one after the other. You can note if you can probably note with my speaker. Okay. Compiled languages converts or translates high-level language to machine-level language. Under interpretation, implementation, there's no translation. The code will be directly interpreted by another program, which is simulated software, right? And the compiler, all code will be sent once after being compiled to the machine for execution. Under interpretation implementation, execution happens line by line. You can note down these points if you want, right? Under compilation, execution is faster. Under interpretation, execution is slower, around 10 to 100 times compared to compilation. Under compilation, less space is required. Under interpretation, requires more space. Under compilation, runtime checking not possible. Under interpretation, runtime errors are easily displayed. Under compilation, the examples of programming language under compilation implementation are C, C++, Pascal, COBOL, Ada, etc. Under interpretation implementation, programming languages, the examples are Lisp, APL, Snowball, all scripting languages such as JavaScript, PHP, Python, ActionScript, VBScript. Okay, these are fine. Am I clear to all of you?
Yes, sir.
Yeah. Now we'll move on to hybrid interpretation. This is how the architecture of pure interpretation is processed, right? You have the source program. The interpreter is a simulated software, okay, which takes your source program and it make the computer to understand your program directly. It means it is almost like a executable files most of the time, like it could be DLL or could be device drivers, like a command kind of thing, right? Hybrid implementation. This is a compromise between the compilers and pure interpreters. A high-level programming language is translated to an intermediate language that allows easy interpretation, faster than pure interpretation. Right? For example, Java comes under this category. It's a compiled and interpreted language, right? Perl is also practical extraction decoding language is also comes under this. Is also one kind of scripting language being used for internet. Comes under this hybrid, right? Programs are partially compiled to detect errors before the interpretation, right? So in this kind of languages, what happens? There will be a virtual machine. For example, when you talk about Java, right? There is a Java virtual machine or a Java runtime environment, we call it as, which is embedded in all the operating systems and browsers, right? So that JRE or JVM is nothing but your interpreter. So what you do before, you interpret your universal bytecodes on this, interpreter is, first you need to compile, right? You write a Java program, save it with Java extension, then you compile it, right? With compiler. So Java compiler is needed to compile the program. Once you compile, you get the, object code. Basically, the object code which is being generated by the compiler is different from the Java, right? So, for example, when you're talking about the compiled implementation, where The compiler then generates the object code of the C language. Okay, so this is the intermediary code. The other way around, you can say, which goes across, is published on the computer to produce the result, right? So in interpretation, in hybrid implementation, like Java, what happens is you first compile the object code which is being generated is the universal byte code. We call it as universal byte code. This cannot be directly given into the machine, right? So this universal bytecode can be interpreted on the Java virtual machine environment, right? So these interpreters will now check this universal bytecodes and make the computer to understand this code in the form of commands, which can rather than produce the result, right? So if you see in hybrid, right, which is fed through the lexical analyzer, it generates the lexical units, which is nothing but lexemes or tokens, rather, right? Are the symbols, right? And these lexical units will now fit through a syntax analyzer, which then produces a parse tree, right? And this parse tree will be fed through an intermediate code generator, will generate an intermediate code. Then it will be given to an interpreter. Then this interpreter is a simulated software which can directly, represent or produce. It can directly produce the code which can be executed by computer to produce you the result. Okay, so here, compared to interpreter languages, this is a bit faster. You say why? Because the compilation process, we do it before, rather, right? We do it before on some machine, and that compiled code you can carry it on to any other machine to get it executed with the help of an interpreter. For example, in case of Java, when Java was invented, as I told you in the last class, that it was invented by keeping in view of internet. So when you are executing Java programs, Java software may not be available on the machine, rather, right? So then how can the Java program get executed on your machine, rather, right? So you have this interpreter built in across all the browsers and the operating system. JVM or the Java runtime environment, right? So which is nothing but the interpreter, you can say, right? So you first compile the code, you can first compile the Java program and generate the universal byte code, that is UBC. These UBCs, universal byte codes, are going to be now carried across any machine where you do not have the Java software available on it, right? That is how you say zero architecture is one of the features of Java, right? You will not have the Java software installed on the machine, though you are able to execute Java programs, right? And you say machine independent is one of the features of Java, because when the species, you can execute on any machine, right? Irrespective of the machine configuration or processor, or the operating system platform, you can execute that, right? So, of course, once the execution starts with the help of interpreter, then that simulation software is just going to produce the proper, commands to the machine. Then the machine is going to produce you the result. So in Java, what happened, in order to increase the execution speed, a just-in-time compiler, we call it as JIT compiler, right? Just-in-time compiler was being added in Java 1.2 version onwards, right? Now we got Java 9 version, right? Anyway, so this JIT compiler worked in conjunction with the interpreter, because when you come to interpreter is going to execute the code line by line, rather, right? So this compilation process you may have finished on some machine before. Now this intermediate code, the universal bytecodes which are fed through this interpreter is going to be executed line by line. So it takes definitely time. So in order to increase the time, what you can do, a just-in-time compiler is added in Java 1.2 onwards, right? So which is there here in parallel to this interpreter working, so that a line will go to interpreter, at the same time another line goes to just-in-time compiler. So both of them are going to execute the code one after the other, and parallel. Hence, the execution rate will be increased. That's how in Java the execution rate has been increased.